Today I want to talk about SQL-based metrics and how we're using DuckDB and ClickHouse to create, I think, faster, more flexible dashboards and BI tools. And in terms of what takeaways from this discussion or this presentation today, I'd like to answer a few questions. One is why I believe metrics are the core building blocks of analytics, why they should be defined in SQL, why real-time databases, DuckDB, ClickHouse, Apache Pinot, Apache Druid, are ideal engines for metrics layers. And then, of course, I'd be remiss if we didn't throw in some AI discussion at the end here and talk specifically about how metrics layers are actually unique in being a curated substrate for conversational AI agents. Okay, so first, just what is Rill? As Carlos mentioned, I've been working in analytics for a couple of decades now. I actually started my career as a computational biologist, initially working with MATLAB, and then I got really involved in the R community. Huge fan of Hadley Wickham's work, early adopter of ggplot2 and the entire tidyverse. And with Rill, I really wanted to kind of go back to basics and think about building a BI tool leveraging some of my own experiences. The very first thing that sets Rill apart is we're designed for fast query engines. We all know that a dashboard is only as fast as the engine it's attached to. And in my experience, the reason why a lot of folks are frustrated with their dashboards is they're slow. It's not the dashboard's fault. It's that Snowflake or BigQuery or Redshift are slow. So we built Rill to work with fast query engines like ClickHouse, like DuckDB, and what we call real-time analytics databases. The second foundation that we've leaned into is BI as code. We're not alone there. Lots of folks are realizing that the pendulum is really swinging from code first, I should say from no-code interfaces, which were a big thing over the last few years, to recognizing that English is the universal interface. Language is a great interface for AI agents. It's got great expressivity. And so using code as the foundation in Rill provides incredible power. We're obviously not alone in recognizing that. But you can develop dashboards locally. I'll show a demo where I'm actually working on my local machine close to the metal. But then you can publish these dashboards globally with Git workflows. And the third thing, and this is of course what today's talk is all about, is our metrics first philosophy. A lot of BI tools historically have used either their own proprietary languages to define metrics or YAML or JSON expressions. I'm definitely inspired by Julian's work. We've really tried to lean into declaring metrics in SQL. I don't think we're all the way there yet. We're waiting for some of the work to mature, but metrics really are measure aggregates that deserve to be expressed in a language that we all know is the lingua franca for data. And once you've defined your metrics layer in Rill, dashboards are auto-generated from that metrics layer. You don't have to think about colors and how big your fonts should be, et cetera. Okay, so I'm going to be brave enough. I have not checked the Wi-Fi, but I think I'm going to be brave enough to try to do a live demo here and just show Rill in action. One of our goals is that we can get from data to dashboard in just a matter of seconds. So this is if you're interested in trying Rill on your own laptop, we have a simple curl command. You can download it and launch it locally. I'm going to switch over here and see if I can actually get this going here. So I've already downloaded Rill. So what I'm first going to just do is type, I'm going to launch Rill. So if you hadn't downloaded Rill, you could do that just with this curl command. That's the latest nightly. I won't do that because it's about 100 megabytes. But once you've downloaded Rill, you can just do, let's check the version. I think I've got the latest. Okay, I'm now going to do Rill start, and I'm going to put this in a temp folder and call it Data Council. We're going to name this project. Put a B on the end of it. Oh no, okay, that's why you don't do lives. I've got another Rill running, but I'm going to restart that. Okay, so I've started Rill locally. You can see it's localhost 9009. That's where we're running this right now. And I've got a few options here. I'm actually going to start, I can add data, a Parquet file, an S3 bucket. I could do that, and these are all the different sources that we support. We can also connect to an OLAP engine like ClickHouse, Druid, or Pinot. But in this case, what I'll do just to keep our life simple is I'm actually going to go and pick a example dashboard. So this is actually a cost monitoring dashboard we built. I'm going to click on this. Uh-oh, this is what happens when you do live demos. The dashboard that I've picked is an OpenRTB. Uh-oh, this is terrible. This is what happens when... Let me see if I can actually restart this and see. Okay. All right, we're going to go with OpenRTB. Oh, no. I'm going to switch over. I'm going to see if I can go back and do and go to the published dashboard. Okay, I don't have internet, so that's my issue. Let's see if we try this again. We can actually get to internet connection. Okay, I'm on mine, so that should work. Let's try this one more time. So, pkill, Rill start. We'll do a Rill start temp DC 2025. And, okay, we're here. Let's try this. Okay, good. Got it working. So what we're doing here is we're actually downloading a set of, essentially a GitHub repository that defines the entire project. So the thing, again, with Rill is that it's BI as code. And on the left-hand side here, what you'll see is we've defined sources, which are basically YAML files that describe where the data lives. We've got a set of models. These are essentially data models. You could think of these as database tables. I've got 2 different tables there. And then we've got our metrics layer. In Rill, we call these metrics views. And these are defined, in truth, the measure aggregates are defined in a combination of YAML and SQL. We sometimes call that SQAML. If we actually look at we have a visual editor here, but we also have behind the visual editor, we've actually got these measures. So something like requests is defined as a sum of bid requests. We've got average bid floor. We're looking at a real-time advertising marketplace data set. So we've defined that as just, again, a SQL expression. And then you've got some other expressions for the dimensions below. And the result of this, once we've defined these models, is we can build dashboards off of this data. So if I look here, it's actually ingesting this data from an S3 bucket. You can see, in this case, it's actually a Google storage bucket. There's about 55 million records that it's ingesting right now. And once that gets brought in, we'll be able to interactively build dashboards that are powered by a metrics model. So I'm going to, like a cooking show, I'm going to swap and let that run in the background. And we'll get back to talking about metrics. And you'll see, once we've loaded that data, what we can do with it. OK. So this is what you would get if you were, once you're able to actually download the data. This is the generated dashboard that we built on top of a metrics layer. And a few things to point out here. This is essentially a visualization, a rendering of a metrics model. On the left, you've got a set of, on the left-hand side, you've got a set of metrics. And on the right-hand side, typically, you've got a set of dimensions. And because this is powered by DuckDB or ClickHouse, every single query is instant. So we're doing drill downs on domain names. We can change the time that we're looking at. We can compare different values. But this is essentially the core experience of Rill, is the ability to slice, dice, and pivot on any aspects of your data. And why do we think metrics are such a powerful building block of analytics? I think if you look at some visualization and BI tools, they really focus on data sets as the core foundation to build charts and tables on. In our view, fact tables are too raw. When you try to build visualizations on top of fact tables, it's challenging, especially when those fact tables are big. On the other hand, reports traditionally, we see people building very kind of rigid reports. Those are they're too baked. They're not flexible enough. And so we think that metrics are kind of the right size building block because metrics can be evaluated in different contexts. They're flexible. So what is a metric? It's an aggregate function whose value depends on the filters and predicates placed on its dimensions. That's a quote from Julian's paper. And we think about metrics. This is something that we all use day to day. We think about revenue. Revenue is a much more intuitive and flexible metric than, let's say, sum of sales. But once you have something like revenue, it's not just a single baked number. Revenue can be, you can look at it by country. You can look at it broken down by product category. You can look at it by over time. And the questions that most people ask in the business world really are questions about metrics. And so analytics applications can flexibly define these different predicate contexts. If you look back at what we're doing with Rill, we are evaluating these different metrics of advertising spend, impression volume. We're evaluating these different metrics in different contexts. That's the core exploration task that people use exploratory BI for. Okay, so the other thing that's great about metrics is they can be calculated off of aggregated cubes. Now, these aggregates are not, we're not materializing 100 or 1,000 different tables. We're materializing an OLAP cube, which is essentially a group by all. It's one of the reasons why we love DuckDB's group by all syntax, is it's a great way to define effectively an OLAP cube, where you would say select sum of price as revenue, comma country, comma product category, comma time, and then group by all. And so these cubes tend to be, in our experience, 10 to 100 times smaller than fact tables. And so one of the great advantages of OLAP cubes is you get sort of a natural compression of your raw data. And one of our customers today is a telecommunications company. They send us about 100 terabytes a month of data, but when we actually build the OLAP cubes, we're only dealing with about a terabyte of data, which is a lot easier to work with than that raw data. Okay, and finally, as I mentioned, metrics are very intuitive. So we've been tabulating data in ledgers, spreadsheets, and pivot tables for centuries. When you give humans the ability to just ask questions about metrics, it's a lot more natural than them asking questions about order tables, sums of price. So why should metrics be expressed in SQL? I think there's a talk that's Andy Pavlo, who runs an amazing database class at CMU. Many of you have probably seen some of his lectures. And he and Michael Stonebracker, another legend of the database world, have written a paper where they talk about historically, the way I would sort of describe this is NoSQL, N-O SQL, eventually becomes K-N-O-W SQL. SQL, again and again, people show up and say, SQL's bad, we should have our own query language. They build their own query language, and then ultimately SQL adopts these new features. I think that the metrics layer, or the ability to define aggregate measures in SQL and extend the table model with measures is, I think, another example of that. The other observation I'll make, which is if you look even now in the world of data engineering, we're seeing SQL go from something that's used in databases, but it's also now being used increasingly in ETL. So I think one of the reasons why data mesh is such a great project is because they really leaned into SQL to define these transformations that you want to do with in your data pipelines. And for those who are interested, I'm interviewing Toby, the founder of Tubico Data, tonight after the Data Council. We're hosting an event there. So if you're interested in hearing more about SQL Mesh, please come by. Okay, so no one wants to learn your garbage query language. This is written by Eric Bernhardsen, who's the founder of Modal Labs. He wrote this a long time ago in his blog, but could not agree more. People really want to be able to use the tools that they have proficiency in, and SQL is one of those, certainly in the data space. And right, so metrics. It makes a lot of sense to define these in SQL. One of the challenges is that SQL dialects can vary a bit. So at Rill, we've sort of standardized on the DuckDB SQL syntax and the ClickHouse SQL syntax for defining these measures. But again, tools like SQL glot allow for transpilation of SQL dialects. So I think we're seeing more and more abilities to move. If you're moving SQL between engines, you can actually translate that fairly easily. And if you're around, Julian, am I right? At 4:15, is that when you'll be speaking? Okay, 4:15, if you want to hear more about measures in SQL, Julian will give a follow-up to his Data Council talk a few years ago. I'll be in the audience looking forward to that. But I think go ahead.
I have to correct you. This year, I'm not talking about measures in SQL. I'm talking about a new garbage query language that I invented.
Okay, so for anyone who didn't hear that, Julian will be talking about morale. Do I say it correctly? At 4:15, he will not be talking about measures in SQL, but you can catch him in office hours and interrogate him more on this paper. I look forward to hearing more about morale. So just to talk about the architecture, how we build a metrics-powered data stack. I think if we look at sort of legacy metric stacks and where we're trying to sort of move away from is the idea of basically having a data lake with orchestration into something like Snowflake as a cloud data warehouse, and then powering dashboards directly off of that cloud data warehouse. What are some of the challenges of this stack, which I think is quite common, is you have inconsistent metrics definitions. You often are actually encoding the definitions of metrics in your BI tool. So without a metrics layer, that's an issue. Many people, of course, are incorporating metrics layers. There's a lot of choices out there. The second challenge, which even if you have incorporated a metrics layer, is slow table queries. One of the most common reasons why we see people migrating from Snowflake, Redshift, or BigQuery to an engine like ClickHouse, Pinot, Druid, DuckDB is speed. And the worst thing about slow table queries is not only are they slow, they're expensive. It's not uncommon for folks to spend quite literally millions of dollars a month when they start having high consumption of dashboards that are powered by raw fact tables in their data warehouse. It's a huge problem. And then finally, we talk about the lingua franca being SQL. When you have different coding languages, when your BI tool is using some proprietary language to define metrics, your database tool is using a SQL tool to define tables, and then you've got maybe pipelines that are written in Java or Spark. There's just a lot of different coding languages, and that's hard. That's a hard problem to contend when you've got issues. And I think my own view is that the modern data stack, unfortunately, in some ways, by having many, many vendors, it's a lot of problems to solve. And so we've even had companies thinking about things like data contracts, which are really solving the problem of like inconsistency between lots of different systems. So let's talk about the example of a DuckDB-powered metric stack. And I guess I would also say one of the other companies and founders that's here speaking is Jordan, the founder of MotherDuck. When I say DuckDB, you could also imagine this appeals or applies to MotherDuck as well. And I also put in ClickHouse here. So this is sort of interchangeable with the real-time analytics databases you're using. So first, what you get is consistent metrics definitions. When you have a metrics layer that's in SQL, you can actually power dashboards, but you can also power schedule reports. You can power alerts. You can power other BI tools if you actually are consistently defining metrics at a layer that's in between your database and your dashboard applications. Other huge advantage is sub-second OLAP queries. So when we make OLAP cubes, we tend to drastically reduce the size of the data, but we also get faster queries. And fast databases, fast dashboards really do transform the experience you can have working with data. I think we've almost taken it for granted that dashboards should be slow, but I think it doesn't have to be that way. And then finally, SQL everywhere. So I think if we look at modern stacks, we're going to see SQL at the application layer, SQL at the metrics layer, SQL in the database, and even SQL in ETL pipelines. I think that's a great dream, and it means that we can move logic in and out of different layers of our stack pretty easily. Okay, what are some challenges? So one of the challenges that a lot of tools try to get around is say, hey, you don't need to do any upfront modeling. Let's just throw all the data in the database, and you can just point at any table you want to build a chart off of that. I think that's an anti-pattern. It's something that's easy to do at first, but it gets quite hard to manage at scale. And so, for a metrics-powered data stack, you really do have to do your metrics modeling up front. And there is that saying, no pain, no gain. It's painful at first, perhaps, to spend time modeling, but you actually get a lot out of that. And I'll mention later, increasingly, these metrics modeling can be done by Cursor or Windsurf or other AI tools. So you're just generating code, but that's much easier than having to write a metrics expression for every single table you query. The second is changes to metrics can be expensive. Depending on your architecture, if you do materialize these OLAP cubes, when you change your metrics definitions, when you change the dimensions in your OLAP cube, you often do need to rematerialize those cubes. And at scale, that can be quite costly. So if you don't materialize your metrics cube, you still have some performance issues because you're not getting that roll up into that 100x compression you get with OLAP cubes. And then, to call out DuckDB specifically, and maybe MotherDuck is making some progress on this, but single node scale still has limits. So for us at Rill, we generally do not use DuckDB beyond, frankly, about 10 to 20 gigs of data. I think with MotherDuck you can scale it a lot more, but we tend to rely on other OLAP engines like ClickHouse and Apache Druid and Apache Pinot if we want to get OLAP engines at, let's say, terabyte scale. Okay, finally, and maybe most importantly, in terms of thinking for the future, is that metrics really are, I think, a powerful curated layer for AI agents. I think if you work with some of the text-to-SQL tools out there, if you throw an AI agent at just a schema with 200 tables in it, it can be quite hard for the AI to figure out that without metrics definitions, that a question about revenue needs to be interpreted into a sum of price on the orders, the orders underscore final, V3 table, which has the right data in it. And so once you create this curated metrics layer, it's just a lot more amenable to AIs to make sense of. There's metadata attached to it. There's descriptions of what these metrics are. And I think this is what today AIs, even with large context windows, still do better with smaller context. And then on the creation side, I would say AI is very powerful at building metrics models. And so sometimes the challenges of writing SQL in your ETL, writing SQL in your metrics layer, I think are overcome by the ability to use AI agents to actually generate those definitions. And that's something you only get when you have BI as code. It's a lot harder, I think, to have an AI go through and do BI as clicks versus BI as code. Okay, I'm going to just go back and see, now that I've been launching this, waiting for this dashboard to come up and see if we actually have something here. Okay, so we do. I was able to bring in this raw data. This is looking at about 1 million rows of auction data. And just sort of go back, we were able to bring in a data set from Google Storage. We brought that in. Because this is running in DuckDB, we can really instantly slice and dice through this data. I built a model on top of that. This is doing some light ETL that I've defined. And then finally, this is essentially the metrics layer defined in SQL. We've got a set of measures here, and you can see each of these are just expressions that go through and define what these different metrics should be. There's a set of dimensions, and the moment I've got this, I will be able to generate a dashboard that's auto-generated on this metrics layer. So this dashboard doesn't actually, there's no code that says make the line blue, arrange these dashboards, these measures on the left and these dimensions on the right. That's kind of all auto-generated based on that metrics layer. This is a very opinionated dashboard, and for probably the last 10 years, Rill and its predecessor product have always focused on opinionated dashboards, but one thing we recently launched just yesterday is the ability to compose unopinionated dashboards on top of your metrics layer. And so this is called Canvas. Canvas is a pretty popular term. I know Slack has a Canvas feature and OpenAI as well. But really the idea is that you can compose different visualizations as you see fit. And so one of the other advantages of a metrics layer is that when you want to add, let's say, a chart, a table, or a KPI here, you're actually adding these charts on a metrics layer. And so we can automatically decide which aggregate measures we want to show. It makes chart building much easier when you build charts off of metrics. You're not thinking about having to define, again, sum of price to be revenue. So we're super excited to have this new offering out there. Rill developers open source. It's free. We've been a huge beneficiary of the open source community. We want to give something back. But we also, of course, have a business model where we can host these dashboards for you if you desire. So I hope you'll check it out. If you're interested in building your BI stack on top of metrics, we look forward to helping you achieve that goal.